So I want to talk about a project that I've been working on that I sort of started working on a couple of years ago before fake news became cool. So it got a lot easier to explain what my topic is. That's good. And it's partly sort of done at the Alan Turing Institute. I also got some funding from the Google Digital News Initiative. So thank you, Alan Turing Institute. Thank you, Google. And there's a really nice quote that was from an article in The Guardian recently, which I think summarizes the sort of motivation for this, which is, in recent years, divergent levels of trust in statistics has become one of the key schisms that have opened up in Western liberal democracies. And I think this really sort of is a more useful thing to say than fake news and so on, because the problem here is that people don't really trust statistics. So you could see a lot of nice equations here earlier today, and I think you're the people who trust them, but you're one of the few. So not everyone, no? Well, it has to be mixed audience anyway. So, and I think a lot of sort of media organizations have been looking at how can they make facts more interesting. And one trend that I find really interesting is the sort of trend of doing more data visualizations and presenting data in a more sort of exciting ways and in ways that will make people curious. So this is a visualization that the New York Times did that looks at Olympic medals over the sort of history of Olympic Games. And you can just, even from the far, if you look at the picture, you'll sort of spot that there's these two gaps, which is the World Wars, when no Olympic Games happened, surprisingly. And then there's this weird peak right there, which is when I think first the United States didn't go to the Olympics in Moscow, and then it reversed the next year. So this sort of picture, this sort of visualization really gives you sort of something to think about, and that's what I think is really nice about it. But of course, it has a couple of problems. Can you do this at home? Well, the New York Times can do it because they have a team of very good programmers, very good data analysts. And basically, they need sort of JavaScript expert, R expert, lots of people behind it. So you can't really easily create this at home. Can you understand how they did it? Well, if they give you source code and you happen to have a sort of PhD in data science, then you can, but that's not really expanding our reach. Can the reader explore further? So if you say, well, this is nice, but what would it look like if we look at, for example, medals for just athletics or medals for just running? That's something you can't easily do here. So the motivation is, can we make these things easier to create so that when you see a chart, now I'll show you a better version of this. This is just to fit it on, make it big enough so that you can see it from the back. But this is a little chart that shows the carbon emissions of China, that's the red line, and the US, that's the blue line, from when? From 1960s until 2010. And that's an interesting chart, and you can be saying, well, look how bad China is. And what we want to be able to do here is to say, first, check how this actually is created, where the data is coming from, and potentially modify it. So I'll switch over here and show you how this was created. And this is a little sort of programming environment that runs in browser where you can name the data source. In my case, that's the World Bank. And then I can navigate through the data source by writing this really basic piece of code. So I can say I want data by country. I'm interested in China. That's not China. This is China. And then I want to see data related to climate change. And then I get this massive list of everything that the World Bank knows about climate change. And if I scroll through this for sufficiently long time, I'll find carbon emissions in kilotons. And with this, I can say, I don't want to improve Chrome experience. I want to create a chart with this data set. And then here, if it fits on the screen, you get to see a nice chart with the carbon emissions of China. So the key idea here is we can make it really, really simple to create these sort of basic data visualizations. And you can really easily recreate the chart comparing China and the US. And the main point here is that now that I have this sort of transparency, I can also make it really easy to change these things. So for example, here, rather than looking at carbon emissions in kilotons, I can look at carbon emissions in metric tons per capita. And this is automatically possible because the chart is not just a static image, but it's actually an embedded script. So if you look at carbon emissions per capita, you can see that this is much higher for the US. So you can really sort of explore what's interesting in the data and get more sort of multiple views on what the data tells me. So that was one example. And the key tricks here, that's where the sort of interesting programming language research happens, is that the programming language, in a sense, can understand the data. So when I type dot, it actually knows what is available in the data source, and based on that, it gives me the available countries or the available indicators. And it all boils down to this really simple programming mechanism where you just type dot, select thing, type dot, select thing. So it's trying to sort of simplify the programming process to the most basic single operation that lets you still do pretty much everything you want. Now, this is a little sort of chart that Jonathan Edwards came up with in one of his talks, comparing programming and spreadsheets. So spreadsheets, you can solve lots of fairly simple problems, some of them fairly sort of advanced, but mostly simple problems. And there's lots of people who can use them. And with programming languages, there's this sort of baseline where even if you pick the simplest language, it's still not going to be easier than you have to learn how to code. And then you can sort of do arbitrary, complicated things. But the idea in this chart is that there's this sort of gap where there are problems that are sort of too hard to do in Excel, but really should be a lot easier than learning how to program in Python. And so the work that I'm talking about tries to sort of find something in this gap where it's not going to let you write the sort of world's most fanciest data dashboard and so on. But if you just need to embed a little visualization in your article, then it can do it really easily. Now, I mentioned spreadsheets because they're another really nice sort of source of ideas. And I'll show you another example. I'll spend a bit more time tweaking the sizes so that it actually fits reasonably well and you can see at least something. Well, I'll make it so that you can see the output, but not quite the code. So here, my data set is this data set of Olympic medals that the New York Times were using. So you have table with what games is it, what discipline, what's the team, and somewhere at the end here, there's what medal they get as well. And previously, I was just navigating through a massive data source, but here I'm going to use exactly the same trick of just typing dot and selecting things to actually do a simple data aggregation. So what I can do here is I can say, filter data dot, games is dot, and it understands what's in the data, what's the data source, and what conditions I can create. So I can say I only want medals from the London 2012 Olympics. And as I'm doing this, the live preview here actually sort of does the nice thing that spreadsheets do, which is shows you what your data looks like. So here's my filtered data. And then I can say group the data. And if I want to create aggregation, what's the medalist with the largest number of gold medals, then I can group the data by athlete. That's not by athlete. This is by athlete. And add some aggregation, such as sum the number of gold medals. And again, you can see that all these sort of aggregation operations, they're in the hints. So I just select the ones I want. Now, this lets me do one more fancy thing, because even the typing dot and selecting options may feel a bit too much like programming for someone. So you can do the same operations just by clicking. So I can say sort by, and then by gold descending, and I get the result with Michael Phelps with four gold medals from the London Olympics. The nice thing here is that as I was constructing the code, even by clicking in the user interface, by doing the sort of spreadsheet manipulation, it actually produces a fully transparent, reproducible script. So this is a piece of code you can paste into your article, and everyone will know how you created your visualization and where the data is coming from, and who you removed from your data set to make your results look the way you want it. So that's the second part. And I want to show you one more example, which was sort of inspired by, well, now we have all these nice tools to actually build sort of transparent and open visualizations. How can we get people more interested in actually clicking on those buttons and seeing, sort of engaging more with the data? This is a project that we built in the Alan Turing Institute together with the research software engineering team. And the webpage, you can find it online at Gamma Turing ACUK. Maybe go there after the end of my talk. This is still a research prototype, so if everyone goes, it will crash and my demo will be ruined. And what this does is that it looks in a sort of very similar way at the spending of the UK government. So we downloaded their nice Excel spreadsheets with the data, saved it as CSV files, and linked it sort of to this one nice name in the code that lets me explore all the data. So if I go here, for example, this is a chart showing the sort of subcategory of the UK spending on social protection for 2015. What's the 5 largest groups? And if I click here, I will see that this actually does say by year 2015, by service, social protection. And then it takes 5. So you might be wondering, what have they removed? And I can just remove this bit of code and say update page. And now you'll actually see all the individual items in the list. So it's more open. You can fiddle with this. And the other part where we thought, how can we get people more curious, is actually before we show you some data, we'll make you make a guess at what the data will look like. So this is looking at 2015 total spending of the UK government in GDP, and these are the top 5 categories or top 5 areas. And the trick here is that you have to make a guess before we actually let you see the data. So what do you think is the largest out of economic affairs, education, social protection, general public services, and health? Shout. Health? So I'll go health here. What's the smallest one? Social protection. And then I'll just put the rest in the middle so that we can move on. And then when I do this, I get to see this nice show me how I did button. And actually, social protection is the largest one. Health is somewhere in the middle. The education isn't doing as badly as we academics like to think. And the rest is there as well. So this is really nice because whenever I show it to people, health always gets the largest one. I think I only sort of once showed it to someone who guessed it right, and they were a journalist working on economics. So that's cheating. Social protection is the largest one because that's where the pensions are included as well, and that's the sort of one largest chunk of the overall spending. But the nice thing here is we sort of made you think about it, and you're probably more likely to remember what the results look like compared to just looking at the chart. And this is, again, sort of inspired by one nice piece of work in the New York Times where they made you draw the rest of the line. But it's a sort of very general idea that you can apply to other things like guessing the splits. We've done one where you have to sort of align events like Brexit to timelines like the cost of pound compared to dollar. But that's a sad exercise, so I won't be showing that here. So to wrap up, I think the sort of main point of this talk is make facts great again. And I started this by saying that sort of people really, there's this gap where people care less and less about statistics and less about facts. And I think it's sort of up to us to make the facts more interesting and present them in a way that will get people interested, that will get people care, and that will get people to question them. So can the transparency and openness help us restore some of the trust in statistics that's decreasing? I hope it can. I think there's a lot of interesting stuff that can be done in this area between spreadsheets and programming. And all the stuff I was showing is actually open source, available on GitHub. If you want to try it for something, do chat with me afterwards. I'll be somewhere around here, and I'll be happy to hear from you. Thanks.